Welcome back for our last session of the Open Hardware Mini Conference. Ironically, many of you have been asking when our much promised firmware update is coming. The reason that we haven't done it yet is because we are testing it, because we don't want to fail and risk potentially bricking all of your badges. So the people who've been with the Open Hardware team the longest, John Oxer and Andy Gelme, are here to give you the final session for today about testing the Swagbadge, looking at how we made sure that what we gave you and shipped out to you was going to be functional. And then we'll be finishing off with a few notes about what we see for the Open Hardware Mini Conference into the future and what we'd like to do with the badge. So I will pass it over to our esteemed hosts.
Great. Thanks, Nicola. Okay, so when I started putting together the first couple of badges, I discovered a problem. I assembled the first 10 and discovered that 3 of them didn't work for various reasons. One of the displays didn't work, or there was something wrong with it, and we had a very high failure rate. And basically the problem is that failure rates compound. If you have a probability of a certain thing failing and you have multiples of them, then the probability of something working is actually the inverse. So the probability of at least one of your devices working is 1 minus the probability of none of the parts failing. So what I found was that the OLED screens, and there are 2 displays on it, had a failure rate of somewhere around 8.7%. Yeah, 8.7%. So the pass rate for the OLEDs was 91.3%, which is terrible. It's a really, really low yield. So what happened was that I ended up having to build a tester for the parts before we actually assembled the boards. And when you look at the 91.3% pass rate, we've got 2 of them. And then there were also some of the Lowlands that failed. We had about a 2% failure rate. When you multiply all those together, you get about an 81.7% pass rate once you combine those parts. And so what we couldn't afford to do was assemble hundreds and hundreds of badges and then discover that 18.3% of them had failed. That was no good. So what I had to do was pre-test every single OLED and every Lowland before we assembled the badges, and then test the complete assembly afterwards as well. And this is what my bench looked like. This is failed OLEDs, and unfortunately they can't really be reworked because the failures seem to be in the controller chip, which is under a blob of epoxy on the back of the display. So they're basically DOA and just nothing that can be done with them. So these all end up getting bundled up and going in the bin, unfortunately. But at least I tested every single display before we got to the point of assembling the boards. And this is a result of testing Lowlands. So what we did was unbag hundreds of Lowlands, plug them in, and flash MicroPython onto them before anything else was connected and any assembly was done, so that we knew that the Lowland itself was functional, at least in terms of its USB interface and being able to put code onto it. So the thing then is that once the whole badge is assembled, we also need to test it as a complete assembly. And the way you normally connect to circuit boards for tests is using things called pogo pins. These are little spring-loaded test pins with a point on the end that make contact with the circuit board and allow you to make test connections. Pogo pins come in a variety of different sizes and different tip types depending on what you're making contact with. The ones I normally use are the B1, Q2 and LM3. And the LM3 in particular is very useful because it allows you to make contact with circular plated through holes on a board. And it makes a very good electrical connection because of the little ridges, the little sharp ridges that run down the side. Now these are normally used with a custom-made test jig which is used in a factory, but there is a little trick that I used for this particular project which simplifies the process of building a test jig. Now anytime that you build a project, you typically will get a number of bare PCBs that you assemble yourself. And so this is a trick that I've used a number of times, which is to build a test jig using bare PCBs without the normal parts fitted. And what you can see here are 2 of the version 1 PCBs from the badge and I bolted them together with 12mm spacers and then soldered pogo pins into the test points on the circuit board. And then I've also soldered a LOLN 32 on it. Now if you look at your badge, you'll see that it's got the SAO headers where you plug things in. They are connected through to I/O pins on the LOLN. So all of the points that we want to test are connected in some way back to the microcontroller. And by building a structure like this, it keeps the pins aligned very nicely because of the space between the two boards. It provides very good lateral support and they end up very accurately placed. So I also 3D printed some little guides that clip into the side. In fact, what I do is super glue them in, and if anybody is interested in the designs for all of this, I'm happy to share it. And so what happens is that you place the board that you want to test, so in this case a badge, on top of the structure. It's guided into place by those 3D printed structures, and you push it down onto the pogo pins, which are spring loaded, and they then make contact. So once you have the contact in place, you can then do electrical testing with whatever your device under, so your device under test, in this case the badge, can be tested by the test jig. And here you can see a view from the side. So the little plastic structures provide a depth guide. So if you push the badge down until it sits on those little flat edges, it depresses all of the pogo pins enough to make good electrical connection with the target board. And so in fact, if AV can make me full screen, I have one of them right here. So this is the tester that I used for testing those 300 odd badges, and you can see that there is a little notch in the bottom of these guides. So the way it works is that I just sit the badge down into the bottom notches, push it down, and then that is now electrically connected. We then have a USB connection available to the badge that we're going to test, and we have a USB connection to the LOLN on the test device itself. Now the way the test is conducted is quite clever, and that is all done using some code that Andy wrote. So if we just go back to the slide, so this is what it looks like with the board on the tester ready to have the test executed. You can see the two USB cables coming down there because both the LOLN on the shield, on the badge, and the LOLN in the tester are connected to a host computer, and that is where Andy's magic software comes in. So I'm going to hand over to him to explain how he manages that side of it.
That's a key for the move forward, slide forward, just spacebar.
Just spacebar should do it.
Great.
Yep.
Okay. Okay. So normally with the mini comps we produce between 30 and 50 kits. And we're there on the day. We get a lot of help from everyone, previous alumni and so on, to help newcomers often build these the workshop kits. And if there's any problems on the day, we can sort of fix them there. This year was obviously not like that. We were shipping not just 30 or 50, but nearly 300 kits or completed boards, and they had to work. We didn't want to deal with, or we didn't want anyone to receive something that's broken, and it could just be just one pin wrong could spoil the whole thing. So we had to completely test every pin and every function, button and OLED and so on the board. And from John's experience with working with Chinese factories to have things fully assembled for commercial sale, and I've had sort of a glancingly similar experience, is we understood that this whole process of testing the parts, then testing the whole thing, and then most importantly using automated testing to a complete test. That's what we sort of emulated. So as John mentioned, we've got a modified Swagbadge. It does the board to test, and then the Swagbadge. So we want to use the same software. We didn't want to write two bits of firmware, and also we didn't want to be flashing all the boards once with one set of firmware, the test firmware, and then another set of firmware, and then things could go wrong there. So we thought if we could just all incorporate this into the firmware we shipped, the testing process, we means we flash once, we test, it also gives the software exercise, and then once we know the board's good, we pack it and send it. We don't touch it again. The other thing that we was able to use this process for is also the time we could put a unique encryption key onto every board, which we're not taking advantage of yet, but it was also part of the logistical process of uniquely identifying a board we knew who it was going to, and that also means we've basically done the like a PGP key sharing party. You know, we've already shared the secrets with you. Okay, so so the next thing that we did is we had a piece of host side Python that talked out both the serial ports and it basically talked to a set of functions on both of the board that was testing and the board under test. So if you look in the if you do look in the repository and under scripts, there's a file called tester.py. That's the host side program that basically over the serial port sends commands basically to the Python REPL. So it basically waits for the machines to boot. It looks at what's coming back from the serial port, and it basically understands where the MicroPython and the ICO firmware is in terms of booting. It says, "Oh right, it's now ready to go. Let's test." And it's almost like as if we were typing functions, Python functions on the machine. And these functions do things like basically set all the pins to a value, set one pin to value, check the pins, write something to the OLED. So basically every aspect of the machine can be set through these little functions, which is simply as if a person was typing them, except we've automated the process. And the sort of things we test for is basically, well, we say, set all the pins low, are they all low? Set them all high, are they high? Set one pin, and you want to make sure that another pin didn't get set. You know, you might say, well, it got set, but did a neighbor get set? So we're doing all these cross-testing. Thanks, John. It's what I needed. And so that's what that firmware did. So it's fairly extensive. And so all the functions that actually on the Swagbadges is in libico test.py, and that's all there. So that was basically the software process. Is there much more we can say about that?
Well, one thing I just wanted to add to that is an issue of scale.
Yes.
And that is something that really hit us. Andy mentioned earlier that we've gone from producing 30 to 50 of something to producing 300 of it. And numbers multiply out very rapidly. So the process of taking a badge and putting it on a tester, if you imagine that it takes, say, 1 minute to put it on, plug in the USB cable, run the test process, take it out, put it aside and be ready for the next one. So 1 minute to do that. When you have 300 to do, all of a sudden you're talking about many, many hours of work. So it's not just, oh, I'm going to sit here for 20 minutes and test them. It's, I'm going to sit here for a day and test them because it takes a minute per device. So everything scales up, and anything you can do to improve the efficiency of the process is a big win.
Yeah, and similarly for the whole assembly process. You know, it's one thing for us to have 30 kits or 50 kits all being built at once at the OHMC in the mornings. It's happened for the last 10 or 11 years. It's a whole other thing when all of a sudden we have to build all 300. It's crazy, the scale.
Yes. Or flashing MicroPython onto each of the lowlands, which takes around 52 seconds, and there's 5 hours gone.
Yeah, these numbers were burnt into our brains.
Yes.
Alrighty, so we get to the next thing.
That keyboard.
Sorry, so many keyboards. Cool. So as we come to the conclusion of today, something we wanted to just briefly mention was what happens from here. So we've the OHMC has been running for many years. It was originally the Arduino mini conference, and hopefully there's been many projects and everyone's had a lot of value over the years. But I was thinking, well, what comes next? And so it's always been a challenge for us to basically have projects that cater for both newcomers and also the people who amazingly come back year after year. We really enjoy their company. And so choices of the projects, the activities and the content is always quite challenging. So it'd be good to get some feedback on that. And also we realise there's other people like Alice at Disturber, who's also put in lots of effort over the years, who also have an interest in providing workshops, and how can we work together to create better open hardware experiences in subsequent years. We attempt each year to address a broader audience, more diversity internally in our own team. We've benefited greatly this year and actually last year from Nicola's involvement. Wow, what a powerhouse Nicola has been, even just today. And this year, because badges were effectively going to all registrants, so we didn't have to think as much about the diversity of the attendees, but it's still in their minds. And then another question comes up, is like many person months go into what is effectively a one-day event for most people, and for us, we were in Melbourne. We were locked down, and then to have been given a project for us to work on kept us. Was a fantastic opportunity, but it's still a lot of effort for one day. And so what we're trying to do is make sure that these projects have longer-term objectives and good consequences. And so one thing is like, well, what if what we're doing for today, and everyone's been participating in, is really a trial run for maybe another conference badge. So be interesting to see what if something like that eventuates, something of e-paper and firmware completed before the date, the due date. So you've got other things to
No, I was just going to quickly answer a couple of questions that have popped up in the chat. So Daryl asked, does the testing stop after the first test failure, or does it continue in the case that the issue may be fixable? So what it does is run all of the tests and then gives you a pass-fail at the end, but it also tells you what test failed. It is verbose in terms of its output. So you can see, for example, if a particular I/O pin had a short circuit to something else, you would be able to pick up what the fault is in the output of the test. And there was also a question, I think it was Martin asked, how many did we have to rework? Not very many.
13 failures?
Yeah, I reworked a couple at the start, but then once I started doing the pre-testing of all of the modules, our yield rate went way up. So we only had a couple that failed after the point where the badge had been fully assembled.
Yeah.
So that was definitely worthwhile doing the pre-testing.
Yeah, frankly, it was a fairly simple board as things go. The people who did the assembly, John and Andrew, are very meticulous and experienced. The solder masks were great, so in this case, the chances for a failure were actually reasonably low. But even so, we still have to test everything.
Yeah, there was a question from David Thornley, who said, did you plan for the test jig in the initial PCB design or cleverly repurpose the PCB? And it was a matter of repurposing the PCB. And this is a trick that I've done a number of times before. I've built many test jigs, like I don't know, like 40 or 50 different test jigs. And sometimes what I will do is design a custom PCB which is specifically for the test jig. In fact, I've got like a dozen custom test jigs just up here on the shelf. But this particular trick of reusing the PCB from the project as a way of making the test jig is very useful, and that's a good trick. So that was one of the reasons I wanted to show it today, is give other people ideas of how to build your own test jigs without necessarily going to the trouble of building something custom. You can use spare bare PCBs with some 3D printed brackets and some pogo pins and make yourself a test jig. Great. I think we are pretty much at the end of the day.
One more slide.
One more slide, yes. So, we just want to say thanks so very much, particularly to Andrew Nielsen. Andrew is one of those people who does incredible things behind the scenes. If you have been along to an Open Hardware mini-conf the last couple of years, you have seen his amazing work, his mechanical design. And of course, John, who was here earlier today, who did a lot of the work. We have to thank Astra for being moral support for late night coding sessions, and of course Andy and Nicola. And there is also
and John. Gotta thank John, man. Like, can you not see the gear that's here? Here's the reason that all of the things even got made, because he's got a little pick and place machine and all the gadgets. John is a legend.
Hardly, but but thank you. And there are many other people who contributed as well. This has been a multi-month process with many people helping out in our Slack and providing feedback and helping with software and input into the design along the way. Also thanks to the LCA organisers and the AV team, who have been amazing. So, yes, hey, thank you, I think Chris and Luke, I think it is.
Just pay no attention to the man behind the curtain.
It's trying to organise an event like this when you don't have a back channel that involves just walking up to people and asking questions. Yes.
Yeah, thanks, guys. Really appreciate it.
It makes it so much harder. So they've done a fantastic job of working behind the scenes to make what you see possible. So thank you very much for being part of the Open Hardware mini-conf this year. And there is going to be a breakout room in Venulus. On the left-hand side, there is a menu for the Open Hardware mini-conf BOF. I think that is going to be running for the duration of the conference, and that will be a place for us to jump on. We can do video or audio or text chat, and we can help you with whatever you need to do with setting up your badge. So, anything else?
I would say, particularly if you're stuck, like if you can't get off square one, let's organise a screen share or something to really get you going. We don't want you stuck with going nowhere. So get in touch. And if those people have got ideas or want to put pull requests and things like that, please do that. And also, if I've noticed some questions like some great ideas like how can you control pixels or turn the LEDs on over MQTT. So many. I've written them all down, but keep all those ideas coming.
Yep.
Thanks.
And the software release. It'll be there.
In a minute now. But I want to say one more last thank you, because we've been developing this for months now and hoping that people would enjoy it. And so I want to say a big thank you to everybody out there past that camera out there around Australia and around the world who received your Swagbadges or are building your Dagbadges, and today watching everything that people have put together just since receiving their badge. Amazing. It's really brought everything to life, and I can't wait to see, if this is what you've managed to do in one day, I can't wait to see what's going to come forward in the next few months. So thank you for joining us on our badgie journey.
Okay.
And thanks, Mark Merlin, if you're still watching, and that person in Tibet who's connected to our server, so MQG server.
All right.
All right. Thanks, everybody.
Thanks, everybody.
Stay
Bye.
safe.
Enjoy the conference.
Bye. High five. High five.